Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Review of Python Basics, Part 2, for the class 12 students of Computer Science. In this video, we are going to discuss about operators and operands, input and output, Python's built-in function, typecasting, comments in Python, sequential statements, selection or conditional statements, iteration or looping constructs. So let's dive in and get started. In Python, operators are special symbols or functions that are used to perform operations on one or more operands. An operand is a value or variable that an operator acts upon. Operators, when applied on operands, form an expression. Same operator can behave differently on different data types. Let's see about mathematical or arithmetic operators, which are used to perform various mathematical operations on numeric data types such as integers and floating-point numbers. These operators include addition, which adds values together. In example 1, we add x and y, which is 13, as output. In addition, second example, we concatenate strings with plus operator. Here, we concatenate strings hello plus world and get the output as hello world. Next arithmetic operator is subtraction. It subtracts the second value from the first value. In example 1 of subtraction, we subtract 30 minus 80, resulting in minus 50. Next arithmetic operator is multiplication, which multiplies two values together. In example 1 of multiplication, we multiply 10 and 3, resulting in 30. In example 2 of multiplication, we have string multiplication. Here, the string hello is multiplied by 5 using the asterisk operator. This operation results in the string being repeated 5 times, generating hello 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 as output. Next arithmetic operator is division, which divides the first value by the second value. In example 1 of division, the expression x/y divides x by y, resulting in 3.3333333333333335. The result is a floating point number. Division operation automatically promotes the result to a float. Next arithmetic operator is remainder or modulus. It returns the remainder of the division of the first value by the second value. In example 1 of remainder or modulus, the expression x modulus y calculates the remainder when x is divided by y, resulting in 1. In this case, 10 divided by 3 equals 3 with a remainder of 1. Next arithmetic operator is exponentiation, which raises the first value to the power of the second value. In example 1 of exponentiation, the expression x exponentiation y raises x to the power of y, resulting in 1000, since 10 raised to the power of 3 is 1000. Next arithmetic operator is integer division or floor division, which performs integer division and returns the largest integer value that is less than or equal to the result. In example 1 of integer division or floor division, the expression x floor division y performs floor division, which divides x by y and rounds the result down to the nearest whole number. In this case, 10 divided by 3 equals approximately 3.3333333333333335, but since floor division rounds down, the result is 3. You can work out the other examples given here. An operator can be termed as unary or binary, depending upon the number of operands it takes. A unary operator takes only one operand and a binary operator takes two operands. In this example, in the expression -5*3 plus 6 to 1, the first minus sign is a unary minus and the second minus sign is a binary minus. The multiplication and addition operators are binary operators. Arithmetic operators in Python have different precedence levels, which determine the order in which the operations are performed, that is from highest to lowest, parentheses, exponentiation, multiplication, division, and modulus, addition and subtraction, Here's an example that demonstrates how the order of operations is determined by operator precedence. In the expression, x equals 5 plus 10 asterisk 2 exponentiation 2/4, first, the exponentiation operator is evaluated. In this case, 2 to the power 2 equals 4. Next, the multiplication operator is evaluated. 10 times 4 equals 40. Then, the division operator, slash, is evaluated. 40/4 equals 10.0. Note that when dividing two integers in Python 3, the result is a float. Finally, the addition operator, plus, is evaluated. 5 plus 10.0 equals 15.0. Therefore, the final value of x is 15.0. Relational operators, also known as comparison operators, are used to compare two values or variables and return a Boolean value, true or false, based on the comparison. In an expression, comprising both arithmetic and relational operators, the arithmetic operators have higher precedence than relational operators. In Python, the following relational operators are available: equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. Here are some examples of how these relational operators can be used. Consider variable x and y are assigned the values 5 and 10 respectively for all these 6 Python statements. In the first statement, it compares the values of x, 5 and y, 10 using the equality operator. It evaluates to false. You can work out the other examples given here. Relational operators are applied to strings also. When the relational operators are applied to strings, strings are compared left to right, character by character, based on their ASCII code values. In the ASCII table, each character is assigned a unique numerical value. The lowercase letters have ASCII values ranging from 97A to 122Z, while the uppercase letters have ASCII values ranging from 65A to 90Z. In first example, it compares two string literals, lowercase hello and uppercase hello, using the less than operator. In this case, the ASCII value of lowercase h in hello is greater than the ASCII value of uppercase h in hello. Therefore, lowercase hello is considered greater than uppercase hello in lexicographical order. It evaluates to false. You can work out the other codes. Logical operators in Python are used to perform logical operations on Boolean values. They are used in control statements and loops to make decisions based on the truth value of expressions. The three logical operators in Python are and, returns true if both operands are true, and false otherwise. Or, returns true if at least one of the operands is true, and false otherwise. Not, returns the opposite of the operand's truth value, reverses the state of operand or condition. Here are some examples of using logical operators. In the given example, it assigns the values 5, 10, and 5 to the variables x, y, and z, respectively. In the first print statement, the and operator returns true if both operands are true, and false otherwise. In this case, the expression x equal to z evaluates to true because x and z both have a value of 5. The expression y greater than x also evaluates to true because 10 is greater than 5. Since both operands of the and operator are true, the overall expression x equal to z and y greater than x evaluates to true. In the second print statement, the or operator returns true if at least one of the operands is true, and false if both operands are false. In this case, the expression x greater than y evaluates to false because 5 is not greater than 10. The expression x equal to z evaluates to true because x and z both have a value of 5. Since one of the operands of the or operator, x equal to z, is true, the overall expression x greater than y or x equal to z evaluates to true. In the third print statement, the not operator reverses the truth value of an expression. If the expression is true, not makes it false. If the expression is false, not makes it true. In this case, the expression x equal to z evaluates to true because x and z both have a value of 5. The not operator then negates the truth value of x equal to z. Since x equal to z is true, not x equal to z evaluates to false. Logical operators in Python also have different precedence levels, which determine the order in which the operations are evaluated. The precedence of logical operators in Python is as follows, from highest to lowest. Not, and, or. Here's an example that demonstrates how the order of operations is determined by operator precedence. X equals true or false and not true, print x. This expression follows the order of operations, precedence, in Python. The not operator has the highest precedence, so not true evaluates to false. Next, the and operator is evaluated. False and not true evaluates to false because one of the operands, false, is false. Finally, the or operator is evaluated. True or false and not true evaluates to true because one of the operands, true, is true. Therefore, the final value of x is true. Shorthand or augmented assignment operators in Python are used to combine an arithmetic or bitwise operation, binary operation, with an assignment in a concise way. Instead of writing x equals x plus y, for example, you can use the shorthand operator plus equals. These operators modify the value of the variable in place, rather than creating a new variable, and can be used with all of the basic arithmetic and bitwise operators. Here is a list of shorthand operators in Python, along with examples of their usage. Pause the video and work out by your own. Membership operators in Python are used to test whether a value or a variable is a member of a sequence, such as a string, list, tuple, or set. Python provides two membership operators, in and not in. First, we will see how to use membership operators in strings. In operator returns true if a character or substring exists in the given string. Not an operator returns true if a character or substring does not exist in the given string. To use membership operators in strings, it is required that both the operands used should be of string type. Substring in string, substring not in string. In this example, it assigns the string hello, world, to the variable my_string. Then, it uses the in operator with the not operator to check if certain substrings are present or not in my_string. In the first print statement, world not in my_string checks if the substring world is not present in my_string. Since world is indeed present in my_string, the expression evaluates to false. In the second print statement, goodbye not in my_string checks if the substring goodbye is not present in my_string. Since goodbye is not present in my_string, the expression evaluates to true. Therefore, when you print the results, the output will be false for the first print statement, true for the second print statement. Identity operators in Python are used to compare the memory location of two objects. They check whether two objects are the same object or not. Python provides two identity operators, is and is not. First one is operator returns true if the left operand and the right operand refer to the same object in memory. That is, both variables are pointing to the same object. var1 is var2 results to true if id of var1 is equal to id of var2. Second one is not operator returns true if the left operand and the right operand does not refer to the same object in memory. That is, both variables are not pointing to the same object. var1 is not var2 results to true if id of var1 is not equal to id of var2. In example 1, Here, it checks if x, list 1, 2, 3 and y equals x, refer to the same object using the is operator. Since both x and y refer to the same list object, the expression x is y evaluates to true. In the second part, a new list, 1, 2, 3, is created and assigned to the variable z. The print statement checks if x and z refer to the same object using the is operator. However, even though x and z have the same values, they are separate objects in memory. Hence, the expression x is z evaluates to false. Therefore, when you print the results, the output will be true for the first print statement, false for the second print statement. In example 2, it assigns the strings hello and world to the variables a and b, respectively. Then, it checks if a is not the same object as b using the is not operator. Since a and b are different string objects, the expression a is not b evaluates to true. In the second part, two separate lists, 1, 2, 3, are created and assigned to the variables c and d. The print statement checks if c is not the same object as d using the is not operator. Since c and d are separate list objects even though they have the same values, the expression c is not d evaluates to true. Therefore, when you print the results, the output will be true for the first print statement, true for the second print statement. Let's discuss about the user input. While writing a program, we need to fetch some input from the user. The values inputted by the user are fetched and stored in variables. First function is the input function. The input function reads a line of text from the user and returns it as a string. Here's an example of how to use the input function to get user input. Example 1. Name equals input of enter your name. In this example, the input function is used to get the user's name from the command line. The user's input is assigned to the name variable, which is then used to print a personalized greeting. When you run this program, it will prompt the user to enter their name, enter your name. The user can then type their name and press enter, enter your name, Alice. The program will then print a greeting that includes the user's name, hello, Alice. On the left-hand corner, you can see how it is practically implemented. You can also use the input function to get numerical input from the user. However, you need to convert the input to an integer or float before using it in mathematical operations. Here's an example. This program prompts the user to enter two numbers, n1 and n2. The int of input function is used to read the input as integers. After obtaining the input from the user, the program calculates the sum of the two numbers by adding n1 and n2 together and stores the result in the variable sum. And calculates the product of the two numbers by multiplying n1 and n2 and stores the result in the variable prod and finally prints the output. If value 20 and 30 are given, the sum is 50 and product is 600. Note that the int function takes a number, expression, or a string as an argument and returns the corresponding integer value. If the argument is an integer value, int function returns the same integer. Example, int of 20 returns 20. If the argument is an integer expression, the expression is evaluated and int function returns this value. Example, int of 20 plus 30 returns 50. If the argument is a float value, int function returns the integer part before the decimal point of the number. Example, int of 20.56 returns 20. If the argument is a string value, int function evaluates the string as integer. Example, int of string 200 returns 200. In Python, eval function is a built-in function that takes a string as an argument, evaluates this string as a number and returns the numeric result, int or float as the case may be. If the given argument is not a string or if it cannot be evaluated as a number, then eval function results in an error. Here's an example of using the eval function. Print of eval of string 50 plus 50 foot results in 100. The eval function is used to evaluate the value of a string. It takes a string as an argument, evaluates the string as a number, and returns the numeric result. But in the second line, print of eval of integer 50 plus 50 results in type error. Typecasting, also known as type conversion, refers to the process of changing the data type of a variable from one type to another. Such data type conversion can happen in two ways: explicit and implicit conversion. Explicit conversion refers to the manual and intentional conversion of a value from one data type to another in a programming language. The programmer forces it in the program. The general form is new_data_type of expression. Let's see some examples. In line 1 of the Python code, converting a float value of 30.0 into an integer type, that is int of 30.0, will discard the fractional part 0 and shall return the value as 30. Next in line 3, converting an integer value of 40 into a float type, that is float of 40, will include the fractional part 0 and shall return the value as 40.0. Next in line 5, the argument for 50.0 is already a float, but since it's passed to the str function, it gets converted into a string representation of the number 450.0. Next, in line 7, the integer 98 represents the ASCII code value for the character b. When chr of 98 is called, it returns the character b. Now, look at the right side. Next is implicit conversion. Implicit conversion, also known as coercion, happens when data type conversion is done automatically during runtime by Python and is not instructed by the programmer. Now, look at the example. An integer value stored in variable n1 is added to a float value stored in variable n2, and the result gets automatically converted into a float value stored in variable n1 without explicitly telling the system. This is an example of implicit data conversion. The reason for the float value not being converted into an integer instead is due to type promotion that allows performing operations whenever possible by converting data into a wider-sized data type without any loss of information. It is also called type promotion. In Python, comments are used to document code and provide context for other developers. Comments are statements in a script that are used to explain Python code and are ignored by the Python interpreter and do not affect the execution of the program. Single-line comment in Python start with the hash symbol and continue until the end of the line. For example, #this is a single-line comment can be written either on the top, right side, or bottom of the statement. Multi-line comments can be created using triple quotes, either single triple quotes or double triple quotes. This is sometimes called a docstring and is typically used to document functions or modules. Look at the example 1, how multi-line comments are used. In addition to describing the purpose and functionality of your code, comments can also be used to temporarily disable code that is not currently needed or to leave reminders for future modifications. Look at example 2. We are temporarily disabling the print hello world code. The way in which the statements are executed defines the flow of execution in a Python program, which is categorized as sequential, conditional, and iterational statements. Python, sequential statements refer to a sequence of statements that are executed one after the other in the order they are written, in a sequential order or linear fashion. Sequential statements are simple statements or compound statements that are executed sequentially in the order, default, as they appear in the code. This picture includes the default flow of statement and is the simplest one. Statement 1 will be executed first, followed by statement 2 and then statement 3. Here's an example of sequential statements in Python. In this example, the statements are executed one after the other in the order, to find the area of a circle as they appear in the code. In Python, selection, or conditional statements are used to control the flow of execution based on a certain condition. They allow the program to choose or decide between two or more possible paths of execution based on the value of a condition. The simplest form is the if statement. The syntax is if condition statements. If condition is true, then the indented statement gets executed. However, it will not do anything if the condition evaluates to false. The execution of the indented statements are dependent on the header. Do not forget to place colon after if condition. Let's see an example. In this program, the user is prompted to enter a number. The program uses an if statement to check if the number is greater than 0. If the condition is true, it means the number is positive, and the program prints the number is positive. There is no else clause, so if the number is 0 or negative, no message will be printed. The second type of conditional if statement, called if-else, provides two possibilities. The condition is an expression that evaluates to either true or false. If the condition is true, then the code block under if statement will be executed, otherwise, the code block under else statement will be executed. In this example, the if statement checks if the value of number is greater than 0. If it is, the program prints the number is positive to the console. If the condition is false, it goes to the else part, that is, the number is negative, the program prints the number is negative. The if elif else statement in Python is used when you have more than two conditions to check. It allows you to execute different code blocks based on multiple conditions. In if elif else statement, each condition is checked in order. If the first is false, the rest is checked, and so on. If one of them is true, the corresponding branch executes, and the statement ends. Here, else is optional. Number of elif is dependent on the number of conditions. Let's see an example for if elif else statement. Program to accept salary from the user and calculate the tax payable. First line prompts the user to enter the salary of a person and stores it in the variable salary. If salary less than equal to 50,000. The next line calculates the tax amount by multiplying 0.055% with the salary value and assigns it to the variable tax. Elif salary less than equal to 60,000. The next line calculates the tax amount by multiplying 0.077% with the salary value and assigns it to the variable tax. Elif salary less than equal to 70,000. The next line calculates the tax amount by multiplying 0.088% with the salary value and assigns it to the variable tax. Now we look into the else part. If none of the preceding conditions are true, the code calculates the tax amount by multiplying 0.10% with the salary value and assigns it to the variable tax. Finally, it prints the original salary value and the calculated tax amount to the console. The condition in an if or elif clause can be any Python expression, even a statement that returns a value, even a none value. A nested if-elif else statement in Python is a structure where you can place one if-elif else statement inside another if-elif else statement. This structure is used when you have more complex conditions that require multiple levels of checks. Let's see an example for nested if-elif else statement. Divisibility checker, to check if a number is divisible by 2 or 3 inch. In this Python program, the input function is used to prompt the user to enter a number. The int function is used to convert the input into an integer so that it can be used in the calculations and conditions of the program. The program uses nested if-elif else statements to check the divisibility of the number by 2 and 3. If the number is divisible by 2 and 3, it prints the number is divisible by both 2 and 3. If the number is divisible by 2 but not by 3, it prints the number is divisible by 2 but not by 3. If the number is divisible by 3 but not by 2, it prints the number is divisible by 3 but not by 2. If the number is not divisible by either 2 or 3, it prints the number is not divisible by either 2 or 3. Let's check the output for this program. If number is 24, the output will be, the number is divisible by both 2 and 3. But when the number is 27, the output will be, the number is divisible by 3 but not by 2. In Python, iterative or looping statements are used to execute a block of code repeatedly. They allow the program to perform the same task multiple times, without the need to repeat the code manually. The iteration construct means repetition of statements depending upon a condition test. The statements will be executed till the condition is true. As soon as the condition becomes false, the repetition stops. There are two main types of iteration, for loop and while loop. For loop is a definite loop. Statements are executed for a definite number of times. While loop is an indefinite loop. Statements are executed until a logical condition remains true. Let's learn about the for loop. The for loop statement is used to iterate or repeat over a range of values or a sequence, such as a list, tuple, or string. The basic syntax of a for loop is for variable in sequence : statements in body of loop, else : statements. In each iteration of the loop, the variable takes on the next value in the sequence, and the code block inside the loop is executed. Here, variable is a variable that takes a new value from the range each time loop is executed. Sequence may be a list, string, tuple. Else statement will be executed after all the iterations of for loop, if provided. Here are some key points to remember for loop. The for loop in Python is used to iterate values from range of values, strings, lists, tuples, or dictionary. Else statement is optional and will be executed after all the iterations of for loop are over. Repeated execution of a set of statements is called iteration. The loop variable contains the highest value of the list after for loop is over. Value of for loop variable cannot be defined beforehand. We shall now discuss about the range function. The range function in Python is a built-in function that generates a sequence of integers, typically used in for loops. The syntax is range of start, stop, step. Can you repeat? Range of start, stop, step. Here, start is an optional parameter. An integer number specifying at which position to start. Default value is 0. Stop is a required parameter. An integer number specifying at which position to stop. Stop value is not included. Step is an optional parameter. An integer number specifying the incrementation. Default value is 1. Here, you have to note that range function is often used in for loops. The arguments of range function must be integers. The step parameter can be positive or negative other than 0. Key points of start value in range function. If start value is not given, the default value is 0. Key points of step value in range function. If step value is positive, move in forward direction. If step value is negative, move in backward direction. If step value is not given, the default value is 1. Key points of stop value in range function. Stop value will not be included. Here are some examples of range function. Range of 10 gives the output 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Range of 1, 11 gives the output 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Range 0, 30, 5 gives the output 0, 5, 10, 15, 20, 25. Range of 0, -9, -1 gives the output 0, -1, -2, -3, -4, -5, -6, -7, -8. Let's see an example. Write a Python program to generate the table of a number using for loop. Here you have to note that the range of 1, 11 used in this program will generate values as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I is loop control variable and will be assigned each generated value, for which the body of for loop will be executed. Now look at the Python code. This code prints the table of a given number. Here's how it works. The code prompts the user to enter a number using the input function and converts the input into an integer using int function. The entered number is stored in the variable num. The for loop iterates over the range of values from 1 to 10 exclusive, using range 1, 11. In each iteration, the loop body executes, which includes a print statement to display the multiplication table. The print statement prints the value of num, the iteration variable I, the multiplication symbol x, and the result of multiplying num by I. After executing the code inside the loop body, the loop moves to the next iteration. This process continues until the loop completes all iterations. For example, if the user enters the number 5, the output will be. The code prints the multiplication table of the entered number 5 from 1 to 10. Now let's learn about the next conditional statement, while. While statement is used to execute a code block repeatedly as long as a certain condition is true. Look at the picture. If test expression is true, the body of the loop is executed. Again, the control condition of the loop is tested and the loop continues as long as the condition remains true. When the test outcome of this condition becomes false, the loop is not entered again and the control is transferred to the statement immediately following the body of the loop. The 4 elements of a while loop in Python are initialization expressions. It initializes the loop control variable and it is given outside the while loop before the beginning of the loop. Next one is the test expression. If its truth value is true, then the loop body gets executed, otherwise not. Next one is the body of the loop. It is the set of statements that are executed repeatedly in loop. Last one is the update expression. It updates the value of loop control variable and it is given inside the while loop. The syntax of the while loop is initialization. While test expression : body of while loop. Code block to execute while the condition is true. Update expressions. In while loop else statement is optional. Here, initialization. It initializes the loop control variable and it is given outside the while loop before the beginning of the loop, while is a reserved word. Test_expression is the condition to be checked for true or false value. Body of while consists of single or multiple statements. Update expressions: it updates the value of loop control variable and it is given inside the while loop. Here is an example of using a while loop in Python to calculate the factorial of a number. The factorial function says to multiply all whole numbers from our chosen number down to 1. The factorial of any number is that number times the factorial of that number minus 1. Now look at the Python code. The user is prompted to enter a number using the input function, and the value is stored in the variable num as an integer. The variable factorial is initialized to 1. This variable will store the calculated factorial. The while loop is used to calculate the factorial. As long as the value of num is greater than 0, the loop will continue executing. Inside the loop, the current value of num is multiplied with the factorial variable, and the result is stored back in the factorial variable. This is equivalent to factorial equals factorial asterisk num. After multiplying, the value of num is decremented by 1 using num equal to num minus 1. The loop continues until num becomes 0. Finally, outside the loop, the program prints the calculated factorial value using the print function. So, when you run this program and enter a number 5, it will calculate the factorial of number 5 and displays the result as 120. Thanks for watching. Watch the upcoming videos. Review of Python Basics Part 3. Strings, lists, tuples, dictionary. You can check the link in the description box below.